Hello students, in this video we will be discussing about FM and PM. See the next problem. It is a assertion and a reason type of question. And what is the options are? Options are common. First option, both assertion and a reason are correct, and a reason is the correct explanation for assertion. Option B, assertion, reason both are correct, and a reason is not the correct explanation for assertion. Option C, assertion is correct, reason is wrong. Option D, assertion is wrong, reason is correct. This is common in the in the previous question, statement 1, statement 2, like assertion, reason here is the given. What is the assertion given? FM and PM both produce different set of frequency band for the same modulation depth. Modulation depth means modulation index. Yes, for the same modulation index, they will produce different. Why? Because you can see the expressions for FM and PM. What is the FM expression? FM expression is AC cos 2 pi FCT plus beta sin 2 pi FMT. What about the PM expression, sir? PM expression is AC cos 2 pi FCT plus beta P cos 2 pi FMT. So there is a phase difference will be there in the message. So that's why we are getting different frequency bands even for SA modulation index also. Assertion is correct. What is the reason he is saying? Let's see. FM and PM vary the carrier phase angle. Phase angle or its rate, both are same. Yes. Here the carrier phase angle, this is called phase. And this is the term added to 2 pi FCT is called phase, students. Yes, this phase and this phase is different. Yes, reason is also correct. Now see, reason is a correct explanation for assertion or not? Here FM and PM will produce the different frequency bands even for the same modulation index because FM and vary the carrier phase angle. Yes, it's looking like a valid meaning. Because of different phase angle, they are producing the different frequency bands. Are you understanding my point? Different frequency bands it is producing. So reason is also correct one for assertion. So you have to take the option A because both are correct and the reason is the correct explanation for assertion. See the next problem. What bandwidth is needed for an FM signal that has peak deviation plus or minus 3K and handles audio signal from 200 to 5 kHz? This is audio signal frequency range, that is the delta F. Now he is saying this is a FM signal. What is the bandwidth formula for FM? Bandwidth equal to 2 times delta F plus FM also you can write. That is nothing but 2 times what is the delta F? 3K plus FM. Actually FM value you have to take. Bandwidth will be highest minus lowest, that is 4.8K you will get. 4.8 and 5 approximately same. So I am taking directly 5K. 3 plus 5, 8. 8 2s are 16 kHz is the bandwidth. So option B is the correct. Suppose for the same, suppose if it is a narrow band, then how to take narrow band means 2 FM, that is 2 times FM is 4.8K because highest minus lowest, that is 9.6 or it might be 10K if I approximate it as a 5 kilo. Narrow band FM value and as well as this is also equal to for AM modulation also. Not mentioned means generally we will go with the wideband FM only. But actually in this problem if you see, if you calculate delta F by FM, which we are getting less than 1 because delta F value is 3K and FM value is 4.8. 3K by 4.8 means generally you will get less than 1 only. But he is not mentioning anything, so I am going with the wideband. If you go, you will get 16, and by the calculation, if you go, you will get a 9.6. But in the ES examination, they given 16 is the key, so that's why we need to assume it is a wideband FM. Clear? See the next problem. A carrier signal at a frequency 100 mega is frequency modulated with modulation index 2. So greater than 1 means wideband FM. By a signal at 2 kHz, at what frequency sidebands are produced? We already know in wideband FM, we are having infinite number of frequency components. And he is asking only about the sidebands. Anyhow, we have one carrier frequency component at FC and next carrier frequency. What is the spectral deviation I told you? FM. So, what are the components? We have FC and FC plus or minus NFM. Of course, here he is asking only sidebands means this one. What is FC given? 100 mega plus or minus N is integer, FM value is 2K. So we are having sidebands for these frequencies for different values of N. Now you can see, if you see the options, option A anyhow wrong, B also wrong, because this is about AM sideband frequencies. And this is also wrong. And coming to the fourth one, you can see 100 plus or minus N into 2K. Of course, 2K is called FM. So where N is the integer, so we are having infinite number of sidebands. So the question based on the FM is having how many sidebands, where it is having. And the gap I already told FM. The spectral gap between the components are FM. Clear? Yeah. See the next problem. This is also on assertion and reason. This is the ESA examination 2003 problem. This is a question. ESC 2003. What is the question, sir? Assertion. Narrowband FM signal can be detected by using envelope detector. Here, narrowband FM signal is similar to AM only, but we cannot detect by using envelope detector because narrowband FM does not have any amplitude variations. What is envelope detector will give you? The positive peak of the signal. But in NBFM, where is the information? In the frequency variations of the carrier signal, it will be there. But envelope detector will give you only the amplitude variation. So what is envelope detector will give you? Simply AC only. Because the positive peak of a FM signal will be AC only, no change in the amplitude. But that AC is not our message. So first one is wrong. If first one is wrong itself, I can go directly, it is a option D. Assertion wrong and the reason is correct. Anyhow, because one is wrong means options we can make it. Anyhow, see the reason. Narrowband FM contains carrier component and two sidebands. Yes. Narrowband FM spectral analysis is same as the AM modulation. What AM is having? One carrier frequency component, remaining will be sidebands. Yes. Reason is correct. Assertion is wrong. Are you following? If you give NBFM signal to envelope detector, what is the output you will get? A constant of AC. NBFM signal means frequency variations, but amplitudes are constant. Na? Envelope detector will give you only the positive peak, which is nothing but AC. See the next problem. Two carriers 40 mega and 80 mega respectively are frequency modulated by a signal of frequency 4 kilo, such that the bandwidth of the FM signals in two cases are same. Bandwidth is same. The frequency deviation in the two cases are in the ratio. Frequency deviation means delta F. What should be that ratio is asking. Anyhow, bandwidth is saying same. What is the bandwidth formula? 2 times delta F plus FM will be same in the second case also. So for difference, this is 1 and this is 2 you can take. And here you can clearly understand this is the same. FM is the same in both cases, which is of course 4K. If FM is also same means obviously delta F also should be same. Because bandwidth is the same. If delta F is also same, then the option C is the correct. Getting my point or not? Here, bandwidth given same, FM anyhow 4K in both cases, then obviously delta F also same in that both case. Same means 1:1 ratio. See the next problem. As the modulation index of an FM signal with a sinusoidal modulation is increased from 0 to 3. From where to where, sir? 0 to 3, sir. The power and carrier component. Carrier component means carrier frequency component only in FM. One of the excellent problem asking in the ESC examination in the long back, as well as in the gate also it came. Option A, increases continuously, decreases continuously. Option C, first increase, attain maximum and then decrease. Option D, first decrease and becomes 0, then increase. What is asking, sir? Carrier frequency component, sir. What is the carrier frequency component formula, sir? What is the PCF, sir? AC square J naught square of beta by 2R. This is the formula for carrier frequency component, sir. Are you getting my point or not? Now, what is this value is depending upon the J naught of beta. I given the graph of J naught of beta versus beta for different values. As beta is increasing, like this is decreasing. 0, 1, this is 2.4, this is 5.5, 8.6 and so on like that. Now he's saying that from where to where, sir? 0 to 3. Somewhere here is the 3. 0 to 3. Now try to see. As you are moving from 0 onwards, it is decreasing. J naught of beta decreasing. So first PCF power is decreasing. When its value becoming 2.4, at 2.4 J naught of beta is 0. So at 2.4, 0. Next, after 2.4, S, even though negative, some value is there. Even if it is a negative also, we are squaring. So when compared to 0, some value is there, and that too it is increasing manner. So later increases. See the options, sir. If you see the options, first is saying only increases, no, only decreases, no. First increase, okay, and attains maximum, no. First decreases, see, first decreases and becomes 0 and then increases. So option D is the correct one. Decreases, becomes 0, increases. Got my point? See the next problem. An FM signal is being broadcasting in the range. Anyhow, the practical FM range is 88 to 108 mega. Having carrier swing. Carrier swing means what? 2 del F. The percentage of modulation is. Are you getting my point or not? Now, in this case, how to calculate the percentage of modulation is the percentage of modulation equal to slightly different formula. Delta F by delta F standard value. What is the delta F here? If you see, this is carrier swing means 2 delta F. What is the 2 delta F, sir? 125. Delta F is 62.5K. What is delta F standard value? From the FCC, Federal Communications Commission, which is an independent body in United States, which regulates this radio, telephone, all these things. According to the FCC standards, what is this value? 75K, sir. Percentage is asking means into 100, sir. Then if you calculate, you will get 83%. This is another way of formula for calculating percentage of modulation in frequency modulation. Given delta F by delta F standard. According to FCC standards, it is 75K. See the next problem. A message signal M of t equal to AM cos 4 pi into 10 cube t. What is the message? AM cos 4 pi into 10 cube t is applied to an FM modulator. Starting near about to 0, means starting from 0, AM is gradually increased. When AM is 2 volt, it was found that carrier component goes 0 for the first time. When carrier frequency component will be 0 first time? Tell me. Whenever J0 of beta is becoming 0, I told that remember some values. When J0 of beta will be 0 for first time? Whenever beta value is 2.4, of course beta formula KFAM by FM. Are you following or not? We need to get the KF value. What is the AM value? 2. And you can see the message FM is 2K. Then this is 2.4, 2 cancelled. I can say KF is 2.4 K per volt, per kilohertz per volt. He is not asking KF. See, keeping AM at 2 volt, he is keeping there. FM is decreased until carrier frequency component goes to 0 for the second time. When it will be becoming 0 second time? Whenever beta is 5.5. Now he is asking value of FM. Yes, follow. KF AM by FM. Then obviously from here FM equal to KF value is 2.4K. AM value is 2 divided by 5.5. Calculate this. You will get 872 Hz. One of the excellent problem. The point you need to understand is here is only the way of asking the question style is different. If he given directly beta value 2.4, 5.5 directly, nothing to solve there. You need to recognize that carrier component is becoming 0 first time. When it will become 0? Whenever J0 of beta is 0. For first time, second time, like that, remember. At least 3 values remember. First value 2.4, 5.5, 8.6. Next value is 11.8. Of course, no need. At least 3 values will be sufficient. See the next problem. From here onwards, another 4 or 5 problems based on the instantaneous frequency. Very, 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 very important. Number of times the questions asked in the gate examination. From calculation of instantaneous frequency, from there calculation of delta F as well as delta phi. These are regular models. First see the problem on instantaneous frequency. Consider an angle modulated signal S of t equal to 10 cos 20 pi t plus pi t square. The instantaneous frequency increases at a rate of, rate means d by dt. You can see the options also, you understand H per second. First calculate Fi. How to calculate instantaneous frequencies, student? Whatever may be the problem given, common formula is 1 by 2 pi into d by dt of the total angle of a angle modulated signal. Whatever may be the expression they are given, if you want to calculate Fi, common formula is, general formula is 1 by 2 pi d by dt of theta I of t. What is the theta I, sir? The total angle, sir. What is the total angle, sir? The total value inside the bracket is called the total angle, sir. Then it is 1 by 2 pi d by dt of total angle is 20 pi t plus pi t square. 20 pi by 2 pi, 10. D by dt of t, 1 plus pi gone, t square will be 2t, 2 also gone, remaining is t. This is what, sir? Fi value you got. After getting Fi value, what is asking is not asking Fi. The rate is asking. How to calculate rate? Rate means dFi by dt. 10 constant 0, dt by dt means 1. Frequency means hertz divided by time means seconds. This is very, very, very important formula in the theory part also I told. So d by dt will be, we got 1. Fi formula, this model we are doing number of questions. See. Of course, what about the option? Option A. Rate means always d by dt. Next, see one of the good problem on the instantaneous frequency. A message m of t as shown in the figure is phase modulating a carrier of 1 megahertz with a phase sensitivity pi radian per volt. Phase sensitivity means Kp value. The maximum and minimum instantaneous frequencies of the modulated signal respectively are maximum and minimum instantaneous frequency. Whatever it may be, what is the formula for instantaneous frequency? In the previous slide given Fi equal to 1 by 2 pi. The total angle of an angle modulated signal. Now, if you see the given message is not a sinusoidal, general one. What is the general expression of phase modulation? Expression number 16. The general expression for PM is AC cos 2 pi FCT plus Kp into M of t. This is the total angle. Substitute here. If we substitute the total angle, 2 pi gone, Fc constant outside, d by dt of t is 1. So Fc plus Kp divided by 2 pi into, d by dt of theta of t. D by dt of M of t. D by dt means what? Slope. When Fi will be maximum, whenever the slope is maximum. Whenever Fi is minimum, slope is minimum. And remaining all values are constant. If you see the graph itself, it's here increasing. How much is the slope? Increasing. Change in y-axis by change in x-axis. Change in y-axis 10 power 5 by 1. So 10 power 5. Decreasing means negative slope. How much? Minus 10 power 5. See here also. Change in y by change in x. 10 power 5 means 100 kilo. 100k. Now follow. Directly I am getting the Fmax. Fmax means this value should be positive. What is the Fc value given, sir? 1 mega. 1 mega means 1000k plus Kp values are, Kp is given pi by 2 pi d by dt of M of t. What is the maximum slope, sir? 100k. This cancelled 50. So this is 1050. What about F minimum? 1000k minus pi by 2 pi, because negative slope you need to take. That will be 950k. Now see the options. 1050 and 950. Here only the thing is, you need to get the common formula for Fi 1 by 2 pi d by dt of total angle. Here I take in general expression, they given general M of t. Differentiation means slope. To get the maximum value, take positive slope. Minimum value, take the negative slope. Slope means change in y by change in x. Got my point? Change in y by change in x axis. Increasing means positive, decreasing means negative, students. See the next problem. One of the good problem this is also. This is a common data. 2 questions I taken, and this is a common data. Let M of t be a periodic triangular wave with a period of 10 power minus 3 seconds. Periodic triangular wave. M of t maximum is 1, minimum is minus 1, means amplitude. The carrier frequency is 100k. First question, the message signal is applied to a FM modulator. The maximum and minimum values of the instantaneous frequencies for FM with Kf equal to 10 kHz per volt are. I am not given options because of space problem. Second question, same message is applied to PM, that is a phase modulator. The maximum and minimum values of the instantaneous frequencies for PM with Kp equal to pi radian per volt are. First to see, what is the instantaneous frequency? Fi common formula. 1 divided by 2 pi into d by dt of total angle. And here, given is not a sinusoidal signal, so take the general expression of FM. What is the general expression of FM, sir? Expression number 11, which is AC cos 2 pi FCT plus KF into integral M of t dt. Substitute the total angle value here, sir. If you substitute the total angle value, what is Fy? You will get 1 by 2 pi. This 2 pi gone, Fc constant outside, so Fc d by dt of t will be 1 plus Kf divided by 2 pi. Integration, differentiation, both are gone, then you will get m of t. Now first calculate f max. When it is max, whenever m of t is max. What is Fc value, sir? Fc value they given as a 100k, 100 plus Kf value is given 10k divided by 2 pi into, and 1 second, expression small mistake we done. I think this is, sorry, 2 pi Kf into integral m of t, sorry. So 2 pi also gone. SFM of t is AC cos 2 pi FCT plus 2 pi Kf into, sorry. What is the maximum value? F max I'm writing. Fc value 100k, and Kf value is given 10k. M of t maximum is given 1 volt. So 100k plus 10k into 1, so 110k. What about F minimum, sir? For calculation of F minimum, you need to take M of t minimum value. Minimum is minus 1. 100 minus 10, obviously 90k are the answers. The same thing is given to PM modulator. What is the general expression for PM, sir? The general expression for PM is AC cos 2 pi FCT plus KP into M of t. No 2 pi there. Now, what is the Fi? This is a common formula. Substitute. Then Fi equal to Fc, because 2 pi gone, d by dt of t is 1 plus Kp divided by 2 pi d by dt of m of t. So Fi expression for PM is coming this one, and for frequency modulation is coming this one. Try to remember. Anyhow, I am using the common formula only. Now d by dt means I need to get the slope, and remaining all values are given. Coming to the slope, it is a triangular wave. Time period is 10 power 3 given. So triangular wave means it will be like this. And he given time period is 10 power 3, 10 power minus 3, sorry. 10 power minus 3 seconds is the time period given. And maximum amplitude is 1, minimum amplitude is minus 1 given. In the total duration of 10 power minus 3 seconds, half of the duration is increasing, another half is decreasing. Means 10 power minus 3 by 2 increasing, 10 power minus 3 by 2 decreasing. Okay. Increasing slope I am calculating. What is the change in y? Minus 1 to 1 means 2 divided by half of the time. So 10 power minus 3 by 2. So obviously its value is 4k. Whatever the negative, obviously minus 4k. Now follow. What if first I am calculating F max? Fc value given 100k plus Kp value given pi. See the question, divided by 2 pi. Maximum slope is 4k. Now pi gone, this 2, then it will be 102k. What about the F minimum, sir? F minimum means here what will come? Minus 2k, so 98k. Only the logic is here, student. It is a triangular wave given periodic 1. Total time it is given 10 power minus 3. So half time will be increased, another half time will be decreased. Slope means change in y by change in x. That logic you need to get. Because d by dt means slope. Anyhow, Fi expression for the general PM we got this one, and for FM we got this one. Anyhow, this expression also I explained directly in the instantaneous frequency. Anyhow, how I got this? This is the common formula of Fi, whatever may be the expression. And d by dt means slope I am saying. See the next problem. An FM signal given as S of t equal to 10 cos 2 pi FCT plus 100 integral minus infinite to t m of lambda d lambda, where m of t is shown in the figure below. the peak frequency deviation of the above FM signal. Peak frequency deviation means what, sir? Delta F, sir. What is the common formula for delta F, sir? Maximum of KF into M of T, sir. Delta phi is Kp into M of T. Whenever they given any general problem, for singleton Kf into Am, I can write any general problem they given, use the general procedure. This is a general formula for delta F. How to find this Kf into M of T? Where I written first time Kf into M of T, I written in the introduction of, tell me, in the introduction of the instantaneous frequency Fi, sir. What is the common formula for Fi, sir? 1 by 2 pi d by dt of M of T, sir. Calculate this, substitute this total angle, 2 pi gone, Fc plus 100 by 2 pi differentiation integration gone into M of T. Now try to follow. Always in the instantaneous frequency Fi, the term added to Fc is called student Kf into M of T. Whatever may be the term added to Fc in the instantaneous frequency is called Kf into M of T. And delta F is max value of that. So delta F equal to, this is becoming as 50 by pi into Kf constant I written outside M of T to get the delta F maximum. What's the maximum is given, sir? 10. So 500 by pi. Very common. General formula for delta F. How to get Kf M of T? Get the instantaneous frequency. This is the general formula for instantaneous frequency. The value added to Fc, whatever may be, that is called Kf into M of T. Take that maximum value of that. So what is the option? Obviously option B. Clear? Any problem they given, use the general procedure. Yeah, see the next problem, one of the interesting one. A singleton modulating signal cos 15 pi 10 cube T frequency modulates a carrier of 10 MHz and produces a frequency deviation of 75K. Find modulation index. Second question, phase deviation produced in the FM wave. Phase deviation in the FM wave. Third, if another modulating signal produces a modulation index of 100 while maintaining the same deviation, find frequency, amplitude of the modulating signal assuming Kf equal to 15 kHz per volt. Sir, what is the first question they are asking, sir? Modulation index, sir. Are you getting my friends or not? What is the modulation index, sir? Modulation index is called beta. What is the beta formula? Delta F by Fm. What is the beta formula? Delta F by Fm. What is the delta F, sir? 75K. What is the Fm, sir? This is omega divided by 2 pi. 15 pi by 2 pi, 7.5. And anyhow 10 power 3 means K. Then it will be 10. S1 is done. What is the next question, sir? Phase deviation in the FM wave. He given is a single tone. What is the single tone FM expression? Expression number 12. The single tone FM expression is, students, SFM of T equal to AC cos 2 pi FCT plus beta sin 2 pi FMT. What is the phase, sir? In any term, phase means the term added to 2 pi FCT is called phase, sir. The term added to 2 pi FCT is called phase. What is the maximum phase deviation, sir? Or phase deviation? Phase deviation delta phi equal to maximum value of phase. That is max of beta sin 2 pi FMT. Then it is nothing but a beta. What is the beta? Just now we got 10. Next, sir. another modulating signal produces a modulation index of 100. Means, third problem I am doing. The third problem, what it is saying? Another modulating signal produces modulation index of 100. So, next beta value is 100. While maintaining the same deviation. Deviation, same. Find frequency and amplitude of a modulating signal. First, if we know the beta, that is nothing but a delta f dash by fm. New values means I am saying dashes. But he said that deviation is the same. What is the deviation value? 75k by fm. Bring the fm this side. 75k by 100. Then it will be fm equal to 750 Hz. Because 75k by 100. Next, what we need, sir? Amplitude, sir. What is another formula for beta also? I can write. This is kf am by efm. Or simple, we can also say delta f is 75k, which is nothing but kf am. Then am is nothing but 75k by kf. What is the kf value given, sir? 15k, sir. Then how much this value, sir? 5. Hedges cancel, holds. So third problem is asking frequency as well as amplitude of the modulating or message or intelligence, all are same. And first two questions are simple, small things only. Anyhow, first one is still very small. Second one is calculation of phase deviation in the FM signal. Take in the FM signal, maximum value of phase is called maximum phase deviation. See the next problem. A carrier A cos omega Ct is modulated by a signal f of t equal to 2 cos 2 pi into 10 power 4 t plus 5 cos 2 pi into 10 power 5 t plus 3 cos 4 pi into 10 power 4 t. That is the signal. Find the bandwidth of FM signal by using Carson's rule. Assume kf is 15k. Also find modulation index. First I will calculate the modulation index. What is the modulation index, sir? Beta equal to kf am by efm. Here I am going for some approximate manner. What is that approximate manner is? Am means I need to take a peak value of that or maximum value of that. For that one, differentiate, equate to 0, get the roots and substitute, you will get the maximum values, maximas and minimas. As approximate manner, how I am going is follow. There are 3 values are there. In that one, what is the max value? 5. So I am going in that approximate manner. Divided by FM. FM means highest frequency only we need to take. If we say all, highest value will be 10 power 5. 10 power 5 means 100k. Then it will be k will be cancelled. This will be 20 and 3, 4. I think 3 by 4. That is the modulation index. What is the second one we need to do, sir? Bandwidth, sir. What is the bandwidth, sir? Bandwidth is equal to 2 times beta plus 1 into FM. FM means highest value only will take. That is 2 into beta value is 3 by 4 plus 1. FM is 100k. Take LCM, sir. 7 by 4. Then it will become 7 by 2. 7 by 2 into 100. So 7 into 50. 50 into 7, 35. So 350k. Got my point or not?